Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter metals and non-metals 10 Cbse. So let's see today's topic. So all metals, they do not react with oxygen at the same rate, right? What means by the same rate? Means that some will react much faster and some will take more time to react. Okay. So different metals show different reactivity towards oxygen. Like for example, if you see potassium and sodium, right? Potassium and sodium reacts vigorously and they catch fire when kept open, right? So with oxygen, the reactivity of sodium and potassium is the highest, right? Okay, so to protect them and prevent accidental fires, what has to be done? So these sodium is kept immersed in kerosene oil, right? So now at ordinary temperature, the surfaces of the metals of magnesium, if you see magnesium, aluminium, right? Okay, zinc, they are covered with a thin layer of oxide. What happens is that magnesium oxide is formed in this case. The protective layer prevents the metal from further oxidation. Now, once this oxide layer is formed, right? Suppose this is my magnesium, and on this, if we keep this open in atmosphere, you'll get what? Magnesium oxide. Now, this magnesium oxide will prevent the inner layer of magnesium from reacting with oxygen in the atmosphere. Alright. So iron does not burn on heating. So if you take iron and you start heating, it will not burn. But iron filings is there. It burns vigorously when sprinkled on the flame of burner. Okay. So copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Right. Same way you'll see that copper, what you'll have copper oxide layer will be formed. Silver and gold do not react with oxygen even at high temperature. Right. So silver and gold, they are not reacting with oxygen even at the high temperature as such. So anodizing is a process of forming a thick layer of aluminium. You'll see that we use many of the kitchenwares, okay, in the kitchen, and on that it is written as anodized, right? Okay, it is written as anodized. Now, what it means by anodized? Anodized is nothing but what we are doing is that we are developing a thick layer. Suppose this vessel is of aluminium, right? So what we are doing, we are developing a thin layer of aluminium oxide on it, right? So the aluminium oxide coats, if we keep aluminium, what we have got aluminium oxide layer on it, right? So it is resistance to further corrosion. So the aluminium inside will be prevented from corrosion, so that will not react with air, right? The resistance can be improved further by making oxide layer thicker. So what we are doing, we are applying a thicker layer of aluminium oxide on this vessel, right? So what will happen, the inner layer of aluminium will be prevented, okay, from being exposed to the atmosphere. Now during anodizing, what is happening, a clean aluminium article is made the anode and is electrolyzed with dilute sulfuric acid, right? Okay, so we use electrolysis process and aluminium article is made as anode, right? Okay, and what happen is that, so you get a thick layer of aluminium oxide on this. The oxygen evolved at anode reacts with the aluminium to make a thicker protective oxide layer. So this oxide layer can be dyed easily to give aluminium article attractive finish. So a lot of finish kitchenwares nowadays you see like this, which are anodized. Now let's see regarding sodium. Sodium is the most reactive of the sample of the metal what we have taken, right? Okay, so sodium reacts vigorously with oxygen. Magnesium, if you see, is less vigorous than sodium. We'll all agree to that, right? But burning in oxygen does not help us to decide the reactivity of zinc, iron, copper, or lead. So we can differentiate between sodium and magnesium. All right. Okay, sodium is most vigorous, magnesium is not. But regarding zinc, iron, copper, and lead, we cannot say the same thing. What we see is that only reacting with oxygen will not give us which of the metal is strong and which is not. Right. So let us see more reactions to derive the order of reactivity of these metals. Okay, because if you see zinc, iron, copper, lead, these are the questionable ones, right? Okay, so what we need to do, we need to see more of the reactions, okay, of these metals as such. So now let's see what happens when metals react with water, right? With water, what happens? So let's collect few of the samples of the same metals, like we have got sodium, magnesium, potassium, right? Okay, so what we'll do, we'll put some pieces of samples separately in a beaker half filled with cold water. Now, first of all, what we are doing, we are taking cold water, right? In that we are putting this sample. Okay, which metal reacted with the cold water, right? Let's arrange them in the increasing order of their reactivity with the cold water. What we see is that sodium, potassium, and calcium reacts with cold water. Sodium, potassium, and calcium, right, reacts with cold water. Okay, the increasing order of their reactivity, right? So it's calcium, potassium, and sodium. Okay, so did any of the metal produce fire with water? Yes. The moment you put sodium and potassium, what happens is that you get fire. Okay, you get fire in this, right? Did any metal start to float after some time? Yes. You'll see that calcium will float after some time. Okay. Now put the metals that did not react with cold water in a beaker. Okay, half filled in a hot water. Now those metals which have not reacted with the cold water, we'll place them in a hot water as such. All right. Now those who have not reacted with even with the hot water, what we are doing, we have to react these metals now react with steam. Okay, so it will react with steam now. So this is the apparatus how the reaction will take place. See what we are doing here. Okay, we have got a test tube here, hard glass test tube. In this we have got glass wool soaked in water, so that if we give it a heat, what will happen, steam will be generated, right? And we have a metal sample which we have kept here, right? And if certain gas is emitted, what will happen, the gas will go through this delivery tube. Okay, right, the gas is going through the delivery tube and we are collecting hydrogen gas over the water. Just see, right? So hydrogen gas has been collected here like this, right? So very simple apparatus is this. So action of steam on metals, right? So see, steam is been given here which reacts with the metal and the reaction will take place. Let's see what type of reaction takes place. Okay, metals reacts with water and what they produce metal oxide and hydrogen, right? Okay, see here what is happening here. See, a metal is there and it reacts with water. Okay, what we get metal oxide and we get hydrogen. Okay, this is a general reaction. Okay, then the metal oxide is there, that reacts with water and we get metal hydroxide, right? Okay, so metal oxide that are soluble in water dissolve in it further to form metal hydroxide, right? To form the alkali, as we know. But all metals, they do not react with water, that we need to understand. Now if you see metals like sodium and potassium, as we have seen earlier, they react violently with cold water. Here you see, you put the piece and here you see how violently it reacts with the cold water, right? Okay, so that's the reason in case of sodium and potassium, the reaction is so violent and exothermic, right, that even the hydrogen immediately catches fire, right? Here you see the reaction. Potassium reacts with water, it gives me potassium hydroxide and the hydrogen, and the heat energy is being given out. Okay, and so the hydrogen release that also catches fire very easily. Here you see sodium is there, reacts with water, we get sodium hydroxide, hydrogen, and heat energy is given out. Okay, and that heat energy which has been produced catches the fire with hydrogen as such very easily. Then let's see regarding calcium. The reaction of calcium with water is less violent, right? Here you see the reaction is less violent. Okay, and the heat evolved is not sufficient for hydrogen to catch fire. Okay, so the hydrogen is released, sir. You see here hydrogen is getting released, and the heat energy which is evolved. Okay, right, it is not sufficient enough so that the hydrogen will catch fire. That's the reason reaction. If you see calcium with water, it gives me calcium hydroxide, right? Calcium hydroxide and hydrogen gas is given out. Now if you see here, calcium start floating. After some time you'll see the calcium will start floating here, because the bubbles of hydrogen gas stick to the surface of the metal, right? Here is it will come up and the bubbles of hydrogen will stick here. Okay, these are the bubbles of hydrogen will stick to the metal, and you'll see that it will start floating on the surface, right? Now magnesium does not react with cold water. Okay, it reacts with hot water to form what? Magnesium hydroxide and hydrogen. See, a magnesium reacting with what? Hot water, right? To give me magnesium hydroxide and hydrogen. Okay, it also starts floating due to the bubbles of hydrogen sticking to the surface, right? See, bubbles of hydrogen, they stick to the surface, it will start floating like that, right? So let's see metals like aluminum, iron, and zinc, they do not react either with cold or hot water. How they react? They react with steam. As we have seen earlier, the apparatus have shown you. All right. So they react with steam. And what they form? They form corresponding oxide, corresponding metal oxide. All right. If you see a aluminium with water, it forms aluminium oxide and hydrogen. Same way iron reacts with water. Okay, so metals such as lead, copper, silver, gold, they do not react with water at all. So today we have seen the reactivity of metals, right, with water, how they react with water, that is the cold, hot, and the steam as such. Okay, how the reactivity takes place, how few of the metals react more violently. So this we have seen. So I'm sure you have understood today's topic. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.